Okay, we're going to be taking a look at law of sines case. This is one of the two triangle cases. It's 4C from your review. So they gave us some information up front. They gave us the angle C, it's 55 degrees. Angle A is 17, or I'm sorry, side A is 17, and side C is 15. Okay, since this is going to be one of those weird cases, the ambiguous case, side angle, I'm going to go ahead and sketch a triangle. I'm going to put the angle that I know in this corner right here, so we'll call that C. Okay, that's going to make this side A, and then I have my pivot point, and this is my swinging leg, 15. Okay, when I run into a case such as this where my angle is acute, I should always check the height. That's one of the first things I want to look at. Okay, so I have H, and I find my height using right triangle trig because I know this angle, I want to know that side, and I know the hypotenuse. So I use 17 sine of 55. Okay, plug this into my calculator, and I find out that H is about 13.93. Now what I'm going to do with that information, I'm going to sort of arrange these three pieces of the triangle in an inequality, seeing that the height is less than my free side, which is less than my static side. Okay, this is the two triangle case. So I know that I'm going to have two triangles here. Alright, we'll do triangle number one first, obviously. And triangle number one is pretty easy to do because I don't do anything different. So here's triangle number one. I start by finding angle A. So I use the law of sines. Sine of C over side C is equal to sine of A over side A. Okay, I'm going to plug this into my calculator to solve for A. I get 68.18 degrees. Alright, so that's angle A. Now that I know angle A and angle C, I can find angle B by taking 180 minus angle C minus angle A. Okay, and this is going to give me angle B is equal to 56.82 degrees. So now I have angle A and angle B. Using angle B and my givens for angle C and side C, I'm going to find side B. So I have 15 over sine 55 is equal to B, the side I want to know, over sine of 56.82. Plug this into my calculator, going to give me a value of 15.33 for angle, or for side B. Okay, now this is what I would get if I didn't do the test case in the first step. So this is the triangle that I would find normally. Now, because I did the test case, I know that there's a second triangle, triangle number 2. And this one is actually pretty easy to find once you know it's there. Okay, because I know that there's a second triangle, I'm going to find a new value for A. I'm going to make A obtuse by taking 180 minus the angle that I found in triangle number 1. Okay, this is going to give me a new value for angle A. So angle A now has a value of 111.82. All I do for the rest of this problem is repeat all of the steps I did in triangle 1 in triangle 2 with the new value for A. Okay, I still have my original constants, what they gave me of angle C, side A, and side C. So I start by finding B over here. I take 180 minus angle C minus my new angle A, and I'm going to get a new value for B. B is now 13.18 degrees. Okay, knowing angle B is enough to allow me to set up another law of sines. So I'll have 15 over sine 55 is equal to side B over sine of 13.18, right? A new value for B. Okay, I solve this. I get B is equal to 4.18. Okay, and I now have two triangles, two different sets of values, and I knew all of that because I checked the height, and my free side was longer than the height, but shorter than the static side. Okay, so that's what you're checking for, and that's how you run through a two triangle problem.